Good morning, fifth graders. Today we are going to start a new topic about chemical and physical changes. It's going to work off of our particles and atoms and things we've learned about before winter break. So that's what we're going to continue with. Before I do that, I want to remind you we have a quiz on particles and atoms and elements on Friday. The study guide is posted in Google Classroom. So if you want to get a head start studying for the quiz on Friday, that would be a good thing to look at. So when you're done with the Ed Puzzle today and the Kahoot, I want you to start on your review. So let's get started here. We're going to look at chemical and physical changes. What's the difference between them? Why are we even learning about it? Okay. So here we go, chemical and physical changes. Matter can change in two ways, and if you remember what matter is pretty much all the stuff in the universe. It's anything with mass and volume, and they're made up of these tiny things called particles. Matter can change in two ways. There's what we call a physical change and a chemical change, and they're pretty different from each other. So let's start with physical changes. Physical changes is when you take something, like let's say this piece of paper here, and you change its shape or size. So I can rip this up into a bunch of small pieces and change the shape and size of this paper. The chemical composition or the particles stay exactly the same. This is made of the same stuff as it was before, it's just in a different shape or a different size. So the chemicals, the bonds that hold the atoms together or the bonds that hold the particles together aren't broken and the particles stay the same. So with a physical change, the particles are staying the same even though there might be a change happening to your matter. Well, what's some examples of physical changes? Crushing a can. When you crush a can, it changes shape and size, but what it's made out of stays the same. When you melt an ice cube, the particles are staying the same. It's still water particles, but they're just changing states. So they're going from a solid to a liquid. When you boil water, this is also a change of state when it's going from a liquid to a gas. Mixing sand with water, you're not actually changing the particles, you're just mixing them together. Just like mixing green and red marbles here. You're not changing what they're made out of. The particles are staying the same. You're just jumbling up the different marbles. When you dissolve something in water, you can usually just set it out, the water will evaporate, and whatever you dissolved in there will still be there. So the particles are the same. You can break something like glass into a million pieces, it's still glass. The particles have not changed. So that's a physical change. So some more examples I have here: melting an ice cube, crushing a can, breaking glass, boiling water, chopping wood. All of these things are either a change of state or you're changing the size and shape, but the particles stay the same. That is a physical change. On the other hand, we have what are called chemical changes. With chemical changes, your particles in your substances are actually changing. So you're breaking apart particles and gluing them, not gluing, but bonding them to different particles. So the particles themselves are changing what they're made out of. So a chemical change is when one substance becomes another substance. The bonds in the particles are broken and they form somewhere else, or they just split apart. So the particles are changing. They're splitting, they're bonding to other particles. The atoms, the molecules, they're rearranging. So substances turn into new things. So when a substance becomes another substance, it becomes something new. That's a chemical change, and the particles themselves are actually changing. There are 5 signs that a chemical change is happening. The 5 signs are: 1, a color change happens. Like let's say you have a white mixture, you add something to it, it becomes bright purple. That would be a color change. If the temperature changes, if you mix two things together and it becomes really hot or it becomes really cold, that's another sign of a chemical change. If a precipitate forms, precipitate is just a fancy word for saying when you mix two liquids together and solids form. Number 4, when light is created. So like when you light a match and that flame is letting off a bunch of light and heat, that is a chemical change. And number 5, this can get confused with changing states. But when a gas is produced, let's say you put two liquids together, lots of bubbles and foaming and lots of gases being produced, that's a sign of a chemical change. But here's where it gets a little tricky. If you're boiling water and it's going from a liquid to a gas, steam, that is not a chemical change, right? You still have the same particles. They're just moving farther apart and moving faster, and they're becoming a different state. So you want to make sure that if you have a gas produced, it's not just changing state, it's actually creating a new gas with different particles. So what are some examples of chemical changes? Iron rusting, it goes from like a cast iron pan is black, it goes from black to red, starts flaking off, that is a chemical change. When you have a bonfire and you're burning wood, light is produced, the logs turn to ash, it's super hot, that is a really good example of a chemical change. Metabolism, that just means when you eat food, you break apart the particles in the food, they go into your cells, obviously, there's gases produced, things like that, so that's a chemical change. When you cook an egg, it changes consistency, it changes color, it goes from clear to white, that is a chemical change. When you bake a cake, we're going to watch a video on this, baking a cake uses a lot of chemical changes, there's lots of signs of chemical changes. A rotting banana, so a banana that changes color from yellow to brown, it also produces gases. If you left it in a bag, it would produce gases that would fill up the bag. So there's lots and lots of different examples of chemical changes. Let's see here, some more examples of chemical changes: burning a match, iron rusting, rotting bananas, lighting off fireworks. Fireworks, you can smell them, they let off gas, they make really bright lights, that's why we like watching them. So those are chemical changes. Another big difference between chemical changes and physical changes is that with physical changes, usually you'll be able to fix the change or make it go back to the way it was. With a chemical change, you can't bring it back to the way it was. You can't make a burned log turn into the log it was before, right? That would be impossible. But when you're chopping wood and you split into a bunch of pieces, you can stick those pieces back together and it can make the shape and size of the object that was the way it was before. So usually with chemical changes, you can't go back and forth. Once you make the change is done. With physical changes, sometimes and quite often you can reverse the change or go the other way. So you break glass into a bunch of pieces, you can melt that glass again, make it that shape. So we have a quick video to watch on how baking a cake is a chemical change. So let me pull that up. Okay.
You know what's a really great way to learn about science? Baking. After all, baking is pretty much just chemistry, and chemistry is the science of different kinds of matter, and how that matter can change. Sure, some of the equipment used in baking and in chemistry isn't quite the same, but both baking and chemistry require careful timing and measuring, and both of them result in the formation of a mixture. For example, you can change matter like eggs, milk, flour, and sugar into a tasty dessert. Now, you already know that a mixture is anything made by combining two or more different things. And some kinds of mixtures, like the fruit salad we had at our picnic, can be separated back into the substances that made them. But that's not true about all mixtures. Sometimes mixing things together makes a whole new substance. We call this a chemical change. But what is a chemical change? A chemical change is a change that occurs when the particles that make up two or more substances are rearranged to form a new substance. Unlike the mixtures from our picnic, chemical changes usually can't be undone. Let's observe an example of a chemical change. Observe, people. We're not trying this at home. When we observe a lit match, we see that the match burns. As it burns, it changes into burned wood and ash. We can't change this ash back into a match, so burning is an example of a chemical change that can't be undone. But wait, there's more. Chemical changes often make matter change color. color, like the blackened remains of the match. Sometimes chemical changes make smells, or release light or gases, and lots of chemical changes require either the giving off or taking in of heat. A burning match gives off light, smoke, and heat. All of these things are evidence that when we look at a burning match, we're looking at a chemical change. Now we can do a simple investigation to show how some chemical changes can yield a seriously yummy result. When we mix the ingredients of a cake, we're mixing together different kinds of matter. Say you have flour, sugar, milk, and eggs. When you put them in a bowl and stir, you're mixing several different substances together to make cake batter. And when you pop this mixture into the oven, after a short time, you have a new substance: cake. Now, before you eat it, let's check this science cake for evidence of a chemical change. Did the reaction give off or take heat? Definitely. The cake batter needed the heat from the oven to change into cake. If we left the batter on the counter, it would stay batter. Is there a color change? Check. The batter in the pan was yellow, and now it's a nice golden brown. Is there any smell? Well, if you've never been in a bakery or some grandma's kitchen or just never smelled a cake baking, then I feel bad for you, because it smells amazing. Were any gases released? Let's look at our cake before and after. Before, we have a wet, gooey batter. After, we have a nice, fluffy cake. As the cake was in the oven, some of its ingredients released carbon dioxide gas. We can see evidence of carbon dioxide when we cut the finished product. All those little holes in the spongy-looking cake are caused by this gas. Our last piece of evidence that we've witnessed a chemical change? This change can't be undone. For example, we can't get the water we put into the batter back out of this cake, even if we were to squeeze it really hard. We'd get crumbs. So let's not try. So, a chemical change is a change that occurs when the particles that make up two or more substances are rearranged to form a new substance. Most of the time, chemical changes can't be undone, and we can tell they're occurring by observing them and noting things like changes in color, release of smell or light, and whether they take in or give off heat. All in all, I'd say that sniffing out chemical changes can be a piece of cake.
Okay, everyone, so that is our first lesson into chemical changes and physical changes at some point in the near future. Probably not this week, but the next time I see you after this week, we are going to do a lab on chemical and physical changes. I would like you to play the Kahoot game now. I have the link on Google Classroom. And I also want you to take a look at the study guide and start working on that. We do have a quiz on Friday on particles, matter, and atoms. I hope you guys have a great day, and I will see you soon.